emergency lights at the school be on something like that, where they turn off?
No, the emergency lights don't come on until the power fails. So when the power fails, we'll have what's known as a relay switch, so that the relay will then turn around and turn on the emergency lights. So the easiest way to think of it is, you notice the doors at the end of the hallway will shut when we have the power, when we have the alarms go off.
Yeah.
So right now they're held open with a magnet. So there's an electric circuit up there that's an electromagnet. When the current goes off, then it's no longer a magnet, so the door is shut. And it's the equivalent thing with the circuit. When circuits are powered, there's a little magnet that holds the circuits in whatever position you want. And when it switches, it goes the other way. The battery is capable of pushing current through that circuit. So when you go out and buy something, you decide how much push you want. If I bought a 12-volt battery, that would be the amount of push that we could have on it. We imagine that the electric current comes out of the battery, flowing in that direction. So we imagine that the battery is a little bit like a pump. It pumps the current up, making it move. We will measure current in amps. Amps is going to measure the number of electrons that flow past in a second. It actually measures 1 coulomb of electrons per second. A coulomb is 6.25 times 10 to the 18th electrons, which is a large number of electrons. You need to know that current is measured in amps. Voltage is measured in volts. The resistance will be measured in ohms. If I have an electric circuit that looks like this, by putting the 2, the 3, and the 1, those guys restrict the circuit so it decides how easy it is to pump through it. If we had higher resistances, it would be harder to push. When I see that current, are you able to see that the same current has to go through every single part of that circuit? So the way I would say that, mathematically, is that the total current is the same at 1, the same at 2, the same at 3. There are some equations which are always true. It is true that if I wanted to look at the total voltage, it will always equal the total current multiplied by the total resistance. It's always true that if you take the voltage in 1, it equals the current in 1 multiplied by the resistance in 1. Now, what I would like to find is how much current is going through this circuit. If it's a lot of current, I need to have big wires, otherwise they will burn up. At your house, in your kitchen, you probably have 15 amps of current in each circuit that you have designed for your kitchen. Depending on when your kitchen was built, you could have as few as only one circuit of 15 amps if you got a really old house. If you've got a newer house, you could have as many as 6 or 8 built into your kitchen. You'd be able to handle more amps and more current. Depends a lot on what you want to plug in. So, without going through a lot of derivations, which I'm happy to do if you'd like, you're going to come up with the result that adding up the resistances is how you find the total. So in this case, 2 ohms, 3 ohms, and 1 ohm. An upside down horseshoe, so on the multimeters, is the symbol for an ohm. There are 6 ohms of resistance in that circuit. This is an always true equation. You can use it for any circuit. In our circuit, we're using a 12-volt battery. We have 6 ohms of resistance. we have 2 amps of electricity flowing through that circuit. The problems are also going to want to know how much voltage is in resistance 1. Yes isn't always true equation. This is where you need to look at the circuit and see that the current is 2 amps. The resistance was 2 ohms. You'd have 4 volts across resistor 1. You'll also see in the book that they call this EMF. EMF is the same thing as voltage. It stands for electromotive force. Same thing happens in circuit 2. 2 amps flows everywhere there. You have 6 volts going through circuit 2. Same thing in circuit 3. What do you folks notice happens if I add up the voltages? They're total. So that's the last thing that only happens in a series. So to summarize, you can find the voltages by adding them up in series. You can find the resistances by adding them up. The current's got to be the same.